Hi, my name is Isaac Osores. I'm the owner of Oso 3D Printworks. And if you had told me 9 years ago when I got my first 3D printer that I'd be using it for much more than printing little trinkets for my desk, I don't know that I would have believed you. Having been so early to the hobby, that's pretty much all I did for the first couple years of having a 3D printer. But as time progressed and I got maybe a little bit more serious about it, I realized that the power of 3D printing is really in the fact that you could come up with an idea that morning, design it, spend some time modeling it, and then by the afternoon actually have something tangible to hold in your hand, whether it's something that you came up with completely originally or a replacement part for something that's broken. And so today I'm actually going to be walking you through a real life example that I had with our kitchen pantry door. There's this enclosure that houses magnets and a piece of metal that allows the pantry door to close and stay shut fully. And that piece had broken in my kitchen some time ago. And I thought at the time this would be a great example of 3D printing a replacement part because the reality is I still don't. I have no idea what that piece is called, and the idea of wandering through the aisles of Home Depot or Lowe's looking for this one piece that I have no idea what it's called. I don't even know where to look for it. Um, it it definitely encouraged me to spend the time to measure all the sides and design it in 3D modeling software, send it to my 3D printer, and try my luck that way. And it ended up working nicely. And so I'm actually going to go ahead and show you what the broken piece looked like. So this is the piece that would house the little metal pieces with the magnets and allow the metal piece on the door to fully close for my kitchen pantry. And it had broken, so I took it off the door frame there, um, and I took measurements of all its sides, all the openings, and I actually took and made drawings of my measurements from the side view as well as the top view. And this becomes important later when I went ahead and modeled it in a 3D modeling software called Fusion 360. And the reality is, in this day and age, for any of these programs, any of these processes, there are a ton of resources online, YouTube tutorials, write ups, blog posts about using Fusion 360 or Tinkercad or any other 3D modeling program on how to get certain shapes and get going in those. But Fusion 360 is the one that I happen to use. I modeled it there based on my measurements and my drawings, and I was able to take that V1, that version 1, send it to my 3D printer, and sure enough, it didn't work. My measurements were a little off. I had to go back to the drawing table and really ensure that I was capturing the right measurements, accounting for any gaps or spaces that needed to be there. And then version 2 came out a lot better. And that's the one that I actually ended up using. And if I could take a moment there to stop and say, 3D printing is excellent for that. They call it rapid prototyping. So if you are coming up with a brand new idea and want to try it for the first time, it's very cost ineffective to model it, print it, and then test it and see if it's exactly what you thought it would do. Does it serve the purpose that you thought? Or is it lacking in something that maybe you didn't account for, but now that you have a tangible item to test, you can actually make those determinations and adjust accordingly. So in this case, right, my version 1 was a little off. Uh, I went back to the model, adjusted it in certain places, printed it again, used very minimal amount of plastic, and was able to come up with a working replacement. And so here I show the working replacement part that I 3D printed at home, installed with the magnets and the little metal pieces. I then went ahead and screwed it back onto the frame and then tested it out, and sure enough, my pantry doors now stay shut. And so, what's really nice about this approach to 3D printing a replacement part is that, for one, I honestly, like I said earlier, I just couldn't figure out what this thing was called and how to look for it. And then two, I really did like the idea of sort of doing it myself, right? Having that sense of empowerment of taking the control of the repairs into my own hands and being able to come up with something tangible, if not just to justify the fact of having a 3D printer in my house. Um, but there was also the possibility of customization, right? I could take that printed piece and actually use what's called a higher infill. So making it more dense on the inside, in other words, making it stronger so that those parts where it failed and broke, perhaps with this new model that I printed at home and customized, it wouldn't break in that same way. Um, and then, of course, the accessibility part of it, right? I didn't have to go anywhere. I just had to spend a little bit of time at home measuring the piece, all the different sides, modeling it, and then sending it to the printer. And then within a couple hours, just having that replacement part in my hand. Didn't have to go anywhere, didn't have to go to the store, didn't have to order it off Amazon. So in that sense, incredibly accessible, right? My my factory is in my basement, in other words. But with all that said, I hope this example has inspired you to consider 3D printing as a possible avenue to make a replacement part. Just keep in mind that the majority of the material used will be plastic, and there are different types of plastic. PLA is the most common and great for general printing. However, if it's something that's going to be maybe exposed to heat or requires a little bit more strength, there are other materials that could be used. So just keep that in mind. But like I said, do consider 3D printing. If you have any questions, please feel free to reach out to me.